Hello everyone, this is Mr. Underkoffler, and this is a very short page of guided notes on finding percent error. Go ahead and follow along as I read this out loud. It says percent error measures the difference between a value, either estimated, expected, or simply just wrong, to the actual value, and then calculates it as a percentage. The steps to finding percent error are essentially the same as finding percent of change, which you might recall involved subtracting and then later dividing. Same things here. Step 1, find the amount of error by finding the difference, which does mean to subtract, between the actual value and the other value. Now, the other value might be an estimated value, might be an expected value, might just be simply a wrong value. Whatever it's referred to in the scenario you're given could depend on the problem. So you're going to find the difference between those two things, the actual value and this other type of value that they're talking about. If you get a negative answer, you're going to actually drop the negative sign. Now, why? Because we want to find the absolute value of the amount of error. If you remember from 6th grade math, absolute value is when you take a number and just keep it positive or make it positive if it wasn't already positive. It's defined as the distance from zero, so you're basically dropping the negative sign when we talk about absolute values. Okay, so that's step 1. Pretty easy, especially with the calculator. Going to subtract. Step 2, we're going to divide. Our numerator, what we'll start with in our calculator, will be the amount of error that we got from step 1. Then we will divide by, and this is important, the actual value. Whatever the real, actual, correct value is, that's what we will divide by. And then we're going to convert that to a decimal, from a decimal to a percent. And we can do that by just moving the decimal point 2 places to the right. Or some kids like to multiply by 100, which does the same thing and moves the decimal point 2 places to the right. Again, the key to success is to make sure your denominator, the number you're dividing by, is the actual, real, correct value. Not the estimated value or expected value or wrong value. What you're dividing by must be the actual, real value. Okay, for example, let's do number 1 together. Tanya believes she will make 30 goals this season. At the end of the season, she only had 25 goals. Still pretty good. But what is the percent error of Tanya's estimate? Round the percent to the nearest tenth if necessary. Okay, so step 1, as you saw from above in your guided notes, we're going to subtract. It honestly doesn't matter what order you subtract in, because if you get a negative, you're going to end up dropping the negative. We're just going to go with the absolute value of this subtraction answer. So we're going to keep it positive no matter what. And now we need to take that number and divide. I like to show my division work as a fraction. If you want to put a division symbol instead, that's fine. Whatever, same thing. Divide by the actual value. So what was the actual amount of goals that Tanya got? It wasn't the 30. That's what she believes she's going to get. But by the end of the season, she actually got 25 goals. And that's why you have to divide by 25 here, not by 30. And that's the most important thing to get right, guys and girls, as you do percent error. Got to make sure you're dividing by the actual amount. Okay, go ahead and do this in your calculator. 5 divided by 25 is 2/10. Now, that's not the answer. And we're not going to round that. We're rounding the percent. So we got to take this decimal point, move it 2 places to the right, or just take this times 100. Same idea. And that's because percent means out of 100. And that's going to give you 20% error. And then you're done. That is the percent error. Pretty simple. Why don't you go ahead and try number 2 on your own? Hit pause now, then hit play when you're ready to see how you did. All right, did you already do number 2 on your own? If not, you better hit pause now, because I'm going to start going over this right now. So we're going to take the 350 people that the school predicted, and we're going to subtract by the actual amount, 420. If you subtract it in the other order, it doesn't matter, because this negative sign that I get for the 70, I'm going to end up dropping it. I'm just going to use the absolute difference here, taking away any negatives. And I'm going to divide by the actual amount of people that came to the game. What was that actual amount? Well, it said on Friday, 420 people came to the game. That's the actual amount of people that came. I know it doesn't say the word actual, but you have to be able to interpret the problem and know what was the prediction, that was up there, and what was the actual amount. So we're going to divide by 420. 70 divided by 420 is going to give us 0.1666666. And yes, some of you might want to put a repeating bar on it, but I'm actually going to advise that you do not, because this is not the percent form yet. And don't round this to the nearest tenth. Don't you dare make this 0.2. We're not rounding this to the nearest tenth. We round the percent to the nearest tenth if necessary. And I got news for you. Since the 6 is clearly a repeating 6, just put a repeating bar on it. It's not necessary to round this. It is necessary if the decimal goes on forever and you have no idea where it repeats. That was not the case here. So 16.6 repeating percent error is the answer for number 2. All right, now that you saw me leading you through problem number 1 and you tried number 2 on your own, let's have you try 3 and 4 completely on your own. Hit pause now, and then once you're done with 3 and 4, then hit play when you're ready to see how you did. All right, I assume you have already done number 3 and 4. Here we go. Now, number 3 is a little tricky. Notice how they gave the time that Denise had to wait in line in minutes, but then they give the expected time that she thought she was going to wait as half of an hour. Well, we got to have it consistent here. It's going to be a lot easier to change a half hour to 30 minutes than it's going to be to change 58 and a half minutes to some ugly looking decimal or fraction of an hour. So let's do this the easy way. Half of an hour is 30 minutes. And if you did not do this, then you better hit pause now, get your eraser and pencil moving, and make the corrections that you need to make, because we got to have minutes subtracted by minutes or hours subtracted by hours. Got to be consistent. All right, that's going to give me negative 28.5. Like I've been saying over and over again, we're going to drop that negative so that way we're doing the absolute difference. Divide by the actual amount of time she waited in line. That actual amount was 58 and a half. Go ahead and divide. That's going to give you 0.4871. And just like I taught you on percent of change, I recommend having 4 digits to the right of the decimal point because you're going to move it 2 places to make it a percent, and you need 2 more. Here's why you need 2 more. You're going to round this percent to the nearest tenth. So you need not just the 7, which is going to be here to the right of my decimal point in percent form, but you need the 1, so that way you know how to round that 7. Is the 1 big enough to make the 7 round up? No, it clearly is not. So that's going to be 48.7% error. And finally, problem number 4. This is a very real life thing in Pennsylvania where we seem to get these predictions of snow and then it ends up being not necessarily close to the prediction sometimes. I mean, weather person's job is hard. Sometimes, especially in this mountainous Pennsylvania area, things can be off. But anyway, so we subtract 9 inches off. We're going to take that difference of 9 and divide it by, well, what was the actual amount of inches of snow that we got? It told you right here, we only got 6 inches. That's what we actually got. So yes, it's possible that the difference that you got from subtracting could be bigger than the actual amount. This can happen. When you divide, that's going to give you 1.5. Don't you dare say that is the percent. We haven't yet taken this times 100 or moved it 2 places to the right to get to the hundredths place value, because percent means out of 100. This is going to be 150% error. Yes, that's a huge percentage of error, but yeah, they were way off. They predicted 15 inches of snow, we only got 6. When you're way off like that, you're going to have a big percent of error. And that's it for this very short page of guided notes on finding percent error. Thank you for watching. We'll see you next time.